Assalamu alaikum dear students, I am Tahir Yusuf from JK College. Today my lecture is for class first year and chapter is 1, that is measurements, and the topic is from the chapter measurements is scientific notation. This is a small topic and you study these notation in your basics or in your early classes like 9th class physics. This is similar to that chapter 1. So scientific notation, when we write any number in standard form or in the power of 10, so this is called the scientific notation. So what is the standard form? Let me write m is any number, and when we can write this number in the power of 10. So this is called the scientific notation. 10 means this is some power like 9, 6, 4 or minus 19. The internationally accepted values have must one non-zero value to the left of a decimal point. While we writing a numbers in scientific notations, we have a number 1, 2, 3.4. So this number should be written as 1.234 into 10 raised power 2. So this is m, this is 10, and this is the power p. So in international system, one non-zero value must be placed when we placing the decimal. So on the left side of a decimal, one non-zero value must be here. Like another example, when we have 0.0012335. So this is not in the standard form because on the left side of the decimal there will be a 0. So by writing in the standard form 1.235 into 10 raised power minus 3. So we can place this decimal to that position. So this power minus 3 indicating the position of that decimal when we change from this to new position. So these two are the standard form or the scientific notation. So this is the basic. So you can make any number in scientific notation. Like you have for practice, you can see your exercise for class 9th and for class first year. So in that two exercises there will be much more question which you can write in scientific notation. Now I am proceed towards another topic, which is prefixes. This is another small topic, and you can see this in detail in 9th class physics. But what are the prefixes or the prefixes of the power of 10? Like these are the certain specific power of 10 which have been given special numbers or special names and symbols which are frequently used in measurement. So in your book page number 6, on that page there will be a table 1.5. So this table contain all the prefixes with symbols and equivalent power of 10. So what are the prefixes, or why we write these power of 10 in the form of prefixes? Let me find. This is prefixes or a unit or letter which are used before SI units, like when we say that force is equal to 6 Newton or 600 Newton. So this is when we write D600, or you can say this is 6,000, like 6,000. So we can write in the form of standard form. So this is 6 into 10 raised power 3 Newton. So this 10 raised power 3 Newton, we can make a prefix for 10 raised power 3, which is kilo. So I can write in the form of prefixes. So we can write 6 kilo Newton. So this is an example. 10 raised power 3 is a power of 10, and for that value or power of 10 we use the prefixes k, which is kilo. So this is a small topic. You can see the table 1.5 which are given many examples of prefixes. Prefixes is any letter or word which is used before SI units. So my next topic is the conventions of using SI units. So how we use the SI units. So for that there are 7 points in your book, page number 6. You can see that points, or remember these points. I can explain these points. The first point is full name of the unit does not begin with a capital letter, even if named after a scientist. Like I can say that the most important unit is Newton. So Newton represents the name of the scientist, and that is equal to Newton. So Newton represents the unit name used for force. So I can write only capital N. So this N makes sense for unit that is equal to the unit which is named for force. So I can write this as Newton. This is also when we not used, or this is also another form of the convention of a unit, SI unit. So this is not a necessary for the capital. First letter will be capital. This is not a necessary for the naming of a unit. So we can write this Newton as like a small letters. So the second point is, this is the first point. The second point is symbol of unit name after scientist has initial capital letter, that is capital N. I can say that is for Newton. So when we just used one letter, so that will be capital letter, which is like Pascal. Pascal is a unit for pressure. So the first letter will be capital and the other is small. So for Hertz, Hertz is another unit. So capital H, that is small. Hertz is the unit of frequency. It's mean for naming or for unit we can use the capital letter first. The number 3, the prefixes micro, milli, pico is written before the unit adjacent to the unit. Like I can say this is a 5 micrometer. or 5 millimeter. So the prefixes is used adjacent, written adjacent to the SI unit. The number 4 is the combination of unit is written each with one space apart. Like we can say that torque is equal to 50 Newton meter. So there will be some space between these two units. So this is the combination of units, and for combination of unit we have having some space between these two, but in using prefixes there will be no space. These two are adjacent. So double, triple, number 5, double, triple and so on prefixes are not used, like 1 microfarad. Maybe this may be written as this. There is no double prefixes or triple prefixes used. For this we can use 1 picofarad, or you cannot write 5 into 10 raised power 5 centimeter. That can be expressed in the form of 5 into 10 raised power 3 centimeter, like this centimeter. So you can write 10 raised power minus 3 centimeter. So number 6 is when a multiple of base unit is raised to a power, the power applied to the whole multiple and not use just the base unit. This is most important convention. So students, this is important for numericals also, because you mistakes there, you will be not remembering this point. So this is important. This is number 6. This is 1 kilometer square. If you have 1 kilometer square, meter square, for this is a unit for area. So this can be written as 1 kilometer whole square. It's mean when you solve this, this is 1 into 10 raised power 3 meter square, and when you solve this, this is 1 into 10 raised power 3 meter whole square. That will become 10 power 6 meter square. So these, when you used only square for the SI unit, this is used for the prefixes which is adjacent to that unit. So you can write this is the multiple of a base unit, so is raised to power, and this power is applied to the whole multiple and not just to the base unit. So this is a very important when you use the formula for area. In next topic, in uncertainty, you find that area is 1.5 centimeter multiplied by 1.5 centimeter. So when you apply both multiplication, the student can write 1.5 centimeter square, and you just put the value of 1.5 multiplied by 1.5. So the answer will be 1.5 multiplied by 1.5. They can write 10 raised power minus 2 meter square. So this is not the 10 raised power minus 2. We must use power on C. So this will becomes 10 raised power minus 4. So this is important. The SI unit power is multiplied to the adjacent prefixes. So before substituting values in the formula to calculate the final result, make sure that all the included physical quantities are expressed in their SI units. So this is the second point for convention of using SI unit. So when you submitted the final results, so you must show that all physical quantities are expressed in SI units. So now I am going to express another simple topic, which is errors and uncertainty. there is your this question will be in your short question answer. What are the errors and how we'll remove these errors? So now first I am going to explain the topic errors. The topic is error and uncertainties. Uncertainty is another topic. So now I'm going to describe the errors. So all the measurements are uncertain to some extent. It is quite different to eliminate all types of the possible errors or uncertainties in the measurements. So in a measurements, the errors may occur due to the negligence or inexperience of a person, using a faulty apparatus, or in a student or teacher using inappropriate method or techniques. So these three are the reason behind the errors when you are doing some measurements. So the number one is the negligence, or you neglect the parameters or other restrictions. And when you use a faulty apparatus, also errors occurs, and inappropriate method or techniques. The sudden environment changes or any other unexpected laboratory mishap may also be cause the errors. So the errors may be divided into three types. The one is personal errors. The number two is systematic errors. And number three, that is random errors. So also we use this random error as a personal error, but here in your book there is another topic or heading. So now explaining the first, personal errors. This error may occur due to the carelessness or improper knowledge about an instrument or incorrect reading of a scale by an experimenter is called personal error. This error may vary to person to person. So how we remove this error? Mean the personal error, when you do not know about the apparatus or for reading, how to note down the readings of an experiment, like when you are doing experiment on vernier caliper, or you are using finding the diameter and you do not know how to use a vernier caliper. So this may cause the errors in your ending result. So these errors are called personal errors. These occurs due to the carelessness or improper knowledge about the instrument or experiment. So how we remove the personal errors? This error can be removed to some extent if the experimenter take care during the measurement of any quantity and have proper knowledge about the measurement instrument. So before starting any measurements or for any experiment, first you should know about everything about the instrument or the knowledge about or regarding the experiment. So due to this we remove the personal errors. Now the second error is systematic error. First the personal and the second is systematic error. This error, you know about this because when you are in class 10, so you should perform your experiment in your physics lab. You should perform vernier caliper or screw gauge experiment, or finding the diameters of a cylinder. So you should know about the error like zero error. So zero error is a systematic error. So what is the systematic errors? The error due to faulty apparatus and poor calibration of the instrument itself. It is called the systematic error. This is also called the instrumental error. This is the error in instruments. So I also give the value or the error behind the systematic error, which is called the zero error. Zero error in vernier caliper or in screw gauge, or also we use this error in spherometer. So this how we can remove the systematic error. This error can be removed by the comparing the faulty instrument with some accurate and standard instrument. The difference of the two can be added or subtracted to the measurements. So at the final results, we compare the faulty apparatus with one which is more accurate. So we compare these two, and the difference between the faulty and the other or the rare or the more accurate instrument, we can add or subtract the difference between these two system or these two instrument. So at the end we add or subtract from the final result. If the error is positive, so you know about zero positive error and zero negative error. So if the error is negative, then it will be subtracted from faulty instrument reading or correctness, and if the error is negative, then it will be added to the faulty apparatus. Now I'm going towards the third error, which is called the random error, or this is also called accidental or statistical error, or this is also called accidental or statistical errors. So when we repeated the measurements or some quantity under same condition that the results in different values of the same quantity, this error is called the random error. Let me say one student should perform an experiment, and he note down the time period of a simple pendulum. So the result of one student is 1.2 seconds. This is T1 for one, and under the same conditions on same apparatus, another student perform experiment and the time period is 1.3 seconds. So another student performs same experiment in same condition, the experiment or the time period is 1.1 second. So when we repeated measurements of same quantity under the same condition, and the result in different values, and the result is different values, so this is called the random error. So how we can remove the random error? So you know about taking averages. When we take averages, like total time is T1 plus T2 plus T3 and divided by 3, so we can take averages of that value, so we get a more accurate value, like we can get 1.2 or 1.25 or 1.2. so this will be the average value. So making or taking average of all the values, so we get the we can remove the random error. So this error can also arise due to the change in temperature, voltage, humidity, or other unknown causes. So maintaining strict control condition in a laboratory, repeating the measurement several times and taking the mean of these measurements can minimize the error. So these are the errors. Now students, now I am proceeding towards a new topic, which is the rounding off number. This is a simple topic, but in physics or in measurements, the quantities are always rounded off to a certain level, or we can say more accurate or insignificant figures. So there are following rules which must be observed while the rounding of a number. First, if the dropping digit is less than 5, that is, the dropping digit is less than 5, then the last retained digit is kept as it is. Like we have a number 12.34311. So at up to second decimal place. So we are rounding this number up to second decimals, second space or second digit. So we are removing this 3. So dropping these 3, the digit at the third place after decimal point, then the correct answer. So we can remove this 3 or rounding up to 2 digits. So we are removing this 3. So 3 is less than 5. 3 is less than 5. So we can write this by 3, 4. So rounding off this number up to 2 decimals. So we can removing this 3 and the last digit is retained as it is. So this is the rule 1. The rule 2 is, if the dropping digit is greater than, this is the dropping digit, and if the dropping digit is greater than 5, then 1 is added to the last retained digit. Like we can say that we have a value 12.34768 is required to round off up to second decimal place. So we are dropping this 7. So the dropping digit is greater than 5. So 1 will be added at the last retained number. So the last retained number is 4. So the 1 will be added. So the last number is 12.35. So the 1, this is plus 1 at the last retained number. So the 4 becomes equal to 5. Now the number 3, if the dropping digit, this is the dropping digit, if the dropping digit is equal to 5, so the following 2 situations may occur. Number 1, if there exists no non-zero digit after the dropping 5 as, let me see, 12.345, or you can say that is equal to 33,500. So in such cases the digit 5 will be dropped and the last digit will be observed. If the last digit is even, if we are dropping this 5 and the last digit is even in this case, and when we drop this 5, the last digit is odd. So first we can say that if the last digit is even, so it kept as it is. It's mean this number becomes 12.34, the last digit retained. And if the number is odd, after dropping 5, the number is odd. So 1 will be added at the last retained number. So this becomes 34. Like if this is 33.5 or something. So by dropping this will be, if we can write, this is 32.3350. So it becomes 32.34. So these are the rules when the last dropping digit is equal to 5. If the last retained number is even, so it can be right as it is, and before dropping digit the number is odd, so 1 will be added. If there exists a non-zero digit at any place after dropping 5, like we can say that we have a value here, this is another b, we can say that we have a number like 26.34501, or another number which is equal to 44.33567. In such cases, the digit 5 will be dropped, and whether the last digit is even or odd, in both situations 1 will be added to the last retained number, that is 26.34501 will become 25.35 by dropping 5, and 44.33567 will become 44.34. So this will be 26.35, and this becomes 44.34. So these are the rules. One small topic will be there. They define significant figures. So you know that significance figures in any measurements are accurately in known digits, and one doubtful digits in any measurement, that is called significant figures. The concept of significant figures is very important and useful. Like I'm going to describe the topic significant figures. So it shows the limit or extent to which readings are reliable. So the significant figures in any measurements, the accurately known digits and the first doubtful digits are called significant figures. Now I am going to describing the rules how we find significant figures in any measurements. So first is all non-zero values are significant, like 25.385 meter is the value. So in this measurements there are 5 significant figures, 1 2 3 4 5. So all are significant figures. Number 2 is 0, and the 0 between two non-zero values. It's mean this 0 is also significant, and this measurement contain three significant figures like 1205, and this digits containing four significant figures. It's mean 0 between two non-zero values, so 0 is also a significant. It's mean 0 may be significant or not. So for significancy, they should be between two non-zero digits. And number 3, zeros to the right of a decimal symbol and to the left of non-zero digits are not significant. Like how? We have a number 0.00063. This measurements contain only two significant figures. How? Because these zeros are using for placing this decimal. So these zeros are not significant. So like this, only these two digits are significant. And all zeros to the right side of the decimal that appear after non-zero digits, all are significant. Like if we have a measurement, the number 4, if I have a value y is equal to 3.000, so these measurements contain four significant figures. So 0 may be significant or may not be significant. It depends upon its nature or how we place the value 0. So number 5 rule is, for an integer number, like I can write a number like 8,000 kg. The zeros may or may not be significant. How? Here the significance of these zeros depends upon the least count of the measuring instruments. If the least count is 1 kg, then there are four significant figures, and the measured value will be expressed as, if we can write is in the form of significant figure, it's mean it is equal to 10 raised power 3 kg. So these measurements can depend on the least count of the instrument on which we can measure the value. So these measurements contain significant figures 4. Similarly, if the least count is 10 kg, then we can write this equation. This value is at 8.00 into 10 raised power 3 kg. So the significant figures are 3. So it depends on the least count of the instrument. So number 6 is, when the measurement is recorded in scientific notation or standard form, like we can write a measurements in a standard form. So only these values are significant. So in standard form, the multiple of 10 are not significant, only the remaining values are significant. So these values having 3 significant, 2, 8, 0. Now for other two types, we describe these values with next topic, but for your homework you can write the page number 10 table for the significant figures, and also write the question given in the exercise. So these are the home tasks. So students, keep watching these videos and subscribe our channel on YouTube, and be safe and prepare your work for your first term. Thank you, students.